Hi everyone, welcome to the DevOps Summit 2022 and thank you so much for being here. My name is Kranthi Manchikanti. I'm an enterprise solutions cloud architect at AWS and I'm passionate about blockchain technology and have been working with different blockchain customers over the last 5 years across the globe. Today, our session is about building NFT marketplaces using Amazon Web Services. I will introduce you to the blockchain and Ethereum concepts. We will focus this presentation primarily on the Ethereum-based blockchains that could be expanded to other blockchains as well. Then we'll expand on the digital assets and tokens, go over the special tokens, NFTs, non-fungible tokens, and their life cycle, NFT standards, as well as marketplaces. We will then dive deep on implementing NFT marketplaces on AWS. So, what is blockchain? A blockchain is an immutable append-only ledger that is shared among a distributed set of participants in a network. Each participant keeps an independent copy of the ledger, which makes it a distributed ledger. So when we talk about a ledger, we think of an accounting ledger with credit and debit transactions. In the case of an immutable ledger, once you make any such transactions, there is no reversing the process. If A sends certain amount of money to B, B has to send the same set of amount back to A in another transaction to reverse it. Another important aspect of the blockchain is the cryptographic verifiability. Every transaction has a signature, who did that, and you can verify the same. Also, in blockchain, there is no central authority and hence decentralized nature because no such single central authority exists. But guess what? Since there is no central authority, there has to be some sort of consensus where all the nodes have to agree that something happened. For example, which could be a correct transaction. Some consensus algorithms including the proof of work, proof of stake. For example, in the case of a Bitcoin blockchain, it uses proof of work, where some node has to do a certain amount of work to prove to the rest of the nodes about a transaction. In the case of proof of stake, in the Ethereum example, you would stake a certain collateral and get access to mint the blocks. The more you stake, the more you have the power to mint a block, and why you do it? Typically for rewards. Together, all of these elements allow two parties to transact with one another by ensuring other parties consent to the transaction and also record the same transaction, which provides the immutability as well as the trust. Now, let's move into a decentralized open source blockchain that has a smart contract functionality. Ethereum. Ethereum is a public blockchain with its foundations from Bitcoin. What Bitcoin did to payments, Ethereum is doing the same to applications. With Bitcoin, you are able to transfer funds between different parties without having a third party being involved. Similarly, Ethereum has this concept of smart contracts that can automate workflows without human interactions. So these smart contracts are simple programs stored on blockchain that run when predetermined conditions are met. They typically are used to automate the execution of an agreement so that all participants can be immediate of a certain outcome without any intermediaries involvement, or even you can save some time. Ethereum has developer-friendly languages for writing smart contracts, Solidity and Viper. And going further into the building blocks, moving on to the blocks in the Ethereum network as like the first building block, to ensure that all the participants on Ethereum network maintain a synchronized state and agree on the precise history of transactions. The transactions are batched into blocks. This means dozens or even hundreds of transactions are committed, agreed on, and synchronized all at once. Another building block is the EVM or Ethereum Virtual Machine, which is the global virtual computer whose state every participant on the Ethereum network stores and agrees on. Any participant can request the execution of arbitrary code on the EVM, and the code execution changes the state of the EVM sometimes. So further building blocks in terms of the nodes. In the Ethereum network, a node is a computer running a piece of software called the client, which interacts with the blockchain network by implementing Ethereum communication protocols, verifies the transaction in the block, as well as store the block data. There are multiple independent networks that implement Ethereum protocol but do not actually interact with each other. And production Ethereum network is called the mainnet. Ropsten, Renkaby, Goerli are some examples of testnets. Going into the gas. So the concept of gas, if you think about it, it's very much similar to the concept of gas in a car. You would need gas as fuel to run your car, and similarly, you would need gas as fuel to run the transaction on the Ethereum blockchain. While you interact with the blockchain, you might change the state of the ledger with new transactions. And to change the state of the ledger, you need to have gas. And the nodes minting will get these rewards in the form of gas. Let me introduce you to the concept of an account as well. An Ethereum account is an entity with an ether being the cryptocurrency of the Ethereum blockchain, has the ether balance that can send transactions on the chain. These Ethereum accounts are either user controlled like humans or deployed as smart contracts, which are code dependent. Transactions which change the state of the Ethereum virtual machine need to broadcast to the network. So there are two types of accounts: externally owned accounts and smart contract accounts or contract accounts. EOAs or externally owned accounts are controlled by users. This control occurs often through software such as a wallet application. Externally owned accounts are simple accounts without any associated code or data storage. So this type of EOA is controlled by and cryptographically signed using a private key in the real world. In the case of contract accounts, a contract account is controlled by code executed by the Ethereum virtual machine. It is also referred to as a smart contract account. These contract accounts have associated code as well as data storage, but not the private keys. So they control themselves. In the case of a smart contract account, once we deploy, they'll be stored on an account and it does not have any private keys. To summarize. So now let's go into digital assets and tokens. When we talk about digital assets, they could be of two types based on their properties: fungible and non-fungible. Fungibility is the ability of a good or an asset to be interchangeable with other good or an asset of the same type. For example, if I give you $1 today and then after a week you give me another $1, it is of the same value. Non-fungibility is the opposite. You give me something like a Mona Lisa painting, with some unique properties, only one exists, or maybe a set of finite number of collection exists, and that's it. There is no replacement for the same. So a digital asset is anything that is stored digitally, is identifiable, and give its owner the rights to use that asset or utilize its real value. Examples of digital assets include cryptocurrencies or tokens that represent properties, artworks, collectibles, domain names, and ownership records. And digital token represents a specific value of the digital asset that can be owned, transferred, or redeemed later. And a digital token can be broadly classified as the fungible ones and the non-fungible ones, with the property fungibility in question. Both fungible and non-fungible tokens could be implemented as smart contracts. So let's go into more detail about NFTs. NFT or non-fungible token is a unique on-chain token representing the ownership of an off-chain asset. The off-chain asset could be an art, a real-world asset like a house, a car, etc. And these non-fungible tokens are designed to be cryptographically verifiable, unique or scarce, and also easily transferable. And leveraging the cryptographic signatures native to the blockchain on which an NFT is issued, one can easily determine the origin as well as the current owner of the asset in question in the matter of seconds. So under the hood, an NFT or a non-fungible token consists of a unique token identifier or a token ID, 157 in this case, which is mapped to an owner, identifier, and stored inside a smart contract. When the owner of a given token ID wishes to transfer it to another user, it is easy to verify the ownership and reassign the token to a new owner. And all credits to blockchain for the same. So where do you buy, trade, or create or manage these NFTs? NFT marketplaces. So an NFT marketplace facilitates the NFT trade and provides the infrastructure and the tools required to buy and sell the NFTs. A non-fungible token is created by an artist, a creator, or license holder through a process called minting. Minting is the process that involves signing a blockchain transaction that outlines the fundamental token details, which is then broadcasted to the whole blockchain to trigger a smart contract function which creates the token and assigns it to its owner. Then you have the buyers, you have the sellers who interact with each other to bid or buy the NFTs from the marketplace. And in the marketplace, as a platform operator, they might charge you for the sales that occur on the NFT marketplaces. So starting with a new technology and tools could become really cumbersome and daunting. Luckily, for NFT smart contract development, you don't need to start from scratch. There are libraries for secure smart contract development, and you can use standards like ERC20, ERC721, and you can start the whole NFT development process by creating a contract that inherits the functions like getting the owner of tokens, get balance of an address from OpenZeppelin ERC721 smart contract, and you have further implementations from the libraries. So while you develop the smart contracts that provides the logic to your NFT applications, your code is being translated after compilation into something called an ABI and the contract bytecode with the help of the compilers like Solidity compiler, for example. ABIs are application binary interfaces. So they define the methods and variables that are available in a smart contract and which we can use to interact with that smart contract. Since smart contracts are converted into bytecode before they actually get deployed to the blockchain, we need a way to know what operations and interactions we can initiate with them. And we also need a standardized way to express those interfaces so that any programming language can be used to interact with these smart contracts. And ABIs, the application binary interfaces, facilitate these functions. So on a high level, this depicts the development flow for the NFT smart contract. So you write the smart contract code, compile and generate the ABI, then migrate the smart contract to the blockchain network using different tools like Truffle, and then build your client applications to interact with the ABI using JavaScript libraries like web3.js. While you go through the entire lifecycle, you have to work through the certain tasks in the NFT lifecycle process. Building the UI application to interact with the smart contract, define other related business logic, define, create and manage the storage for the NFTs, implement the event synchronizer, for example, for your reporting and analytics functionalities. And these are not the exhaustive list of tasks, but the primary ones. So now let's look into different application components that are required for building the NFT marketplaces and facilitate these tasks mentioned. So you need a user interface for buyers, sellers, as well as creators. You would also need a storage component to store the required assets details, and a mechanism to render them to the applications as required. You would also need a blockchain node to interact with the global Ethereum network for transactions. So now let's look at some of the AWS services that can help facilitate these functionalities. For building the NFT marketplaces, starting from the user interface for buyers, sellers, and creators, so you can leverage Amazon S3, CloudFront for storing the static files or serving your content. You can also use S3, Amazon Simple Storage Service, for storing your NFT assets. So you can use Amazon Cognito for authentication purposes, and API Gateway for API management and also securing the login mechanisms. So you can leverage AWS KMS, Key Management Services, as well as Lambdas to store the sensitive data using KMS and also process them using the Lambdas. Finally, let me also introduce you to Amazon Managed Blockchain, AMB. So if we dive deep into AMB, so when I typically interact with the blockchain customers, they express the blockchain challenges implementing specific blockchain use cases in the production grade. They start with setting up the blockchain network, which is hard, and these networks require you to basically stitch a lot of infrastructure together and lots of manual effort to configure things securely as well as efficiently. And also, things are really hard to scale, especially with Ethereum. Adding more nodes means more infrastructure to maintain, and the management is not easy. Managing security, governance, data, and all of these could be really cumbersome. And of course, the expenses. So to tackle these challenges, let me introduce you to the AMB, or Amazon Managed Blockchain. So AMB is a fully managed service that makes it easy to create and manage scalable blockchain networks using popular open source frameworks, including Hyperledger Fabric and Ethereum. So instead of creating the infrastructure, maintaining and managing it, so you can leverage the managed node services to focus on building your NFT applications. Using these managed services in the application development enables you to accelerate your development process and minimize the human errors that occur at the infrastructure layer. So what are some of these features? The fully managed aspect, while AWS manages the infrastructure, so you can completely focus on building your applications. You can spin up blockchain nodes in minutes, whereas opposed to days and weeks. So AWS makes sure the node is in sync with Ethereum global network using AWS enterprise grade technologies, so which provides the reliability and scalability for your applications. Also, while you build the NFT marketplaces, you have other services that could be integrated to manage, observe, or even maintain your applications. So now let's see a general purpose NFT application in action using a sample reference architecture. So this illustrates how AWS services can be used in tandem with Ethereum nodes on Amazon Managed Blockchain to create a full stack decentralized application. On the left side of the graphic, you will see a fairly traditional method for distributing a client application, serving static content like a React frontend, for example, via CloudFront distribution, which is a global content delivery network from AWS. So the API requests to the backend can be served through Amazon API Gateway, for example, which acts as a trigger for the backend functionality in AWS Lambda. AWS Lambda, a serverless compute service. In this architecture, AWS Lambda serves as a proxy to one's Ethereum nodes in AMB, Amazon Managed Blockchain, enabling load balancing between multiple nodes to broadcast signed transactions to the network. AWS Lambda can be used in tandem with Secrets Manager, which can store cryptographic keys, AWS credentials, and other secrets in order to perform signing operations with AWS Lambda, or even append AWS SigV4 headers for requests to AMB, Amazon Managed Blockchain. KMS, or AWS Key Management Service, can also be used here to store cryptographic keys and sign transactions on the back end, for example, in custodial environments. To read data from the blockchain, one can use Fargate cluster to orchestrate containers that use the open source Web3 libraries to subscribe to on-chain events from Ethereum. And you can write the data to an off-chain database like, highly scalable NoSQL database, Amazon DynamoDB. So once the data is in DynamoDB, one can use a service like Amazon AppSync to easily create a flexible and a performant GraphQL API to query the extracted data as they need. So all of these services, along with the DevOps tools like Code Build, Code Star, and Code Deploy, can accelerate the application development process. So with that, we have explored the blockchain, Ethereum, as well as NFT fundamental technologies. And we explored the NFT marketplaces as well, and how you can leverage AWS services to accelerate your business. So thank you so much for joining me today. And now let's get to work.